This is a short video to give you a little help in learning about igneous rocks and using the igneous rocks identification key. Igneous rocks are identified by two major characteristics. First is their composition, this kind of first half of your table here, which minerals make them up, and this largely shows up as making them different colors or shades. The second characteristic we'll use in the bottom half of the table is texture, but we'll start with composition. So the first step here is to determine whether you think a rock is light. These tend to shade in kind of whites or yellows. Medium, kind of halfway in between. This sample I've picked out has about half dark, half light crystals. Sometimes medium igneous rocks are kind of in the pinkish shades, pinkish or reddish, or dark here, pretty obvious here. Light rocks are called felsic, and that's because they have lots of potassium feldspar. You'll see that adjective also on the identification table for light colored. Dark rocks are called mafic. They tend to have a lot of basalt in them. Igneous rocks of the same type can vary an awful lot in color. I'm sure that doesn't surprise you. You know, the minerals even that make up an igneous rock can vary a lot in color. So certainly you've probably seen granite ranging from very light to very dark. It'll give us a start. We'll certainly need to use other characteristics for defining and determining an igneous rock. The mafic index that you're seeing right here, you'll read a little bit about in lab, and I would guess you'll be hearing a little bit about in lecture as well. It's actually a percentage you could assign to an igneous rock based on the ratio of light crystals compared to dark crystals. So 0% on this scale would mean that there are no dark crystals in the rock. 100% would mean that there were completely dark crystals in the rock. This one that I've chosen is dark. I would probably rank as something like 85% because I can see some light crystals in there. To really identify a mafic index for an igneous rock, you need to be able to count and measure the crystals, and you need much bigger rock samples to do that. So we want you to be aware that mafic index is another measure of the composition of an igneous rock. We're just going to assign them as light, medium, or dark. To finish describing the composition of a rock, you'll see that there's this row here for dominant minerals, the minerals that make up the rock. And I'm going to use an example of basalt, as in page 4 on the lab. That's the dark sample that I've got right here. So to determine the dominant minerals, what you do with this igneous rock key, identification key, is move down within a column to identify the characteristics once you've determined the color of the rock. So if I move down, I'm going to move my piece of basalt down. I find that the dominant minerals in a dark igneous rock that is largely dark crystals are olivine or pyroxene, and also plagioclase feldspar, the darker of the two types of feldspar, the kind of pinkish type. You'll see that even within a column, within a particular color of igneous rock, there is variation in the exact percent of different minerals making up the rock. If we had a specific mafic index determination, if we knew where we were, for example, between 45% and 85% dark crystals, we could make an estimate of the exact volume of the different minerals in that igneous rock. So you can see, for example, that as the mafic index increases for dark rocks, they'll contain progressively less of this kind of ochre color, this plagioclase feldspar, at least ochre color on the identification key, and more of the olivine. We're not going to do that since we aren't determining specific mafic index. So you'd simply need to write down olivine, for example, and plagioclase feldspar would be the dominant minerals. So if you've identified color and dominant minerals, you're done with characteristics of composition. So now, let me move us down a little bit. We are going to look at texture for the igneous rock, the second half of the table. And texture is results when crystals form in the igneous rock as it cools. You know that igneous rock forms when molten material cools. Read carefully for more detail in the lab, but in general, the slower the crystals form, as when magma can only cool very slowly under Earth's surface, the bigger the crystals. The more rapidly the rock cools, as happens when lava cools on Earth's surface, the smaller the crystals. Igneous rocks that form below Earth's surface with these big grains are called intrusive. I think of that as they form in the interior of the Earth, below Earth's surface. And igneous rocks that form up on the surface, above the Earth's surface, are called extrusive. Think about that as forming on the exterior of the Earth. So the simple way to determine texture is to first determine whether you can see visible crystals. Generally, these need to be about 1 millimeter or so. You can remind yourself of 1 millimeter on the metric ruler for you to see them with your naked eye. So in our sample, I don't see any visible crystals. I would need a magnifying glass to see crystals in this. So this rock would be called fine-grained. If I move down, we've got two choices. We've got either coarse-grained or fine-grained. I would call this one fine-grained because I don't see visible crystals in it. The other word for this in geology is aphanitic. An awful lot of terms, I realize, in this course. I'll give you a study guide before the lab quiz so you know which ones are important and which ones are not. I'm not likely in the lab quiz to test you on aphanitic. Again, we're just trying to expose you to things you might get in a subsequent geology course. So we would determine that this rock was basalt. It's dark, it's fine-grained, it's mostly olivine and plagioclase feldspar. You probably remember that basalt is very common on the ocean floor. It forms at tectonic plate boundaries when new ocean floor is forming, for example, at divergent boundaries. If a rock has very big crystals that you can actually identify with your naked eye, like this one I had as the middle sample, we call it coarse-grained. You might think of chopping something coarsely. That means you chop it into relatively big pieces. I can definitely, you can even see the sparkle. I can definitely make out dark crystals and light crystals that are about at least 1 millimeter in size. So a coarse-grained rock is also called phaneritic. So this middle sample is something coarse-grained. I'll leave it up to you to identify. There are a few much less common textures that all result from volcanic activity, porphyritic and glassy and fragmental. And honestly, the one you're most likely to see in your boxes is glassy. What happens here to give a rock a glassy texture is that the material cools so rapidly that the molecules can't even arrange themselves into crystals, so you get natural glass. And the glass isn't always smooth, as you might expect. Say with man-made glass, the glass can have a very rough texture. So a good example of something that is called glassy, but that doesn't have the smooth glass texture you might expect is number 40 here, is pumice. This one's really interesting. If you look at it closely, I don't know if you can even tell in the video, but when you're holding it, you'll be able to tell. It's got a very pitted surface. It's full of holes. Those holes are called vesicles, and they form when gas is escaping from the very, very rapidly cooling rock. It means that the pumice ends up with a very, very low density. It's very, very light. You can tell that it will float. It feels like almost nothing in your hand. If you feel the surface, though, you can tell why geologists identify it as having a glassy texture. It's very, very rough. You can imagine it cutting. And in fact, if you think about what we use pumice for, we use it to remove dry skin from elbows and heels. So you know that glassy can be this very spun glass texture as well. So good luck. The basic technique is to identify your igneous rock by color, and then make sure you move down a particular column to identify all of its characteristics.